section 1.5 on solving absolute value equations and inequalities. We don't have any vocab terms this time, but you should remember from previous math classes that the absolute value of a number is that number's distance from zero. So that's your vocab term, but we don't have it written down. We do have very important concepts. So we have that the absolute value of A is equal to A, and the absolute value of negative A is also equal to A. So your absolute value is going to be a positive number because it's always, like I said, that number's distance from zero. We want to remember that if you're dividing in an inequality with a negative number, you have to flip the sign. So we did that in section 1.4, and we're going to do it again in section 1.5. And when solving absolute value equations, you're going to always have two solutions. You're going to set up two equations, so you're going to get two answers. Example 1 says solve the absolute value equation. So our absolute value equation says that the absolute value of 3x minus 9 minus 5 equals 22. And the first thing you want to do is you want to make sure to get the absolute value by itself first. Before we start solving, we want to get the absolute value by itself. So I'm going to add 5 to both sides. So I have the absolute value of 3x minus 9 is equal to 27. And from here, I'm going to set up my two equations. So I have 3x minus 9 equals 27, and 3x minus 9 equals negative 27. So you have this number and then the opposite of that number. So I'm adding 9 to both sides and dividing by 3. And on this side, I have one solution of x equals 12. And I do those same steps over here. I add 9 and divide by 3, and I get my answer of x equals negative 6. So again, you're creating and solving two equations. I have x equals 12 as in the answer, and x equals negative 6 as the answer, because you have two answers when you solve absolute value equations. Our second example says solve the absolute value inequality and write your solution in interval notation. So my absolute value inequality says the absolute value of negative 2x minus 5 is greater than or equal to 5. So I'm setting up my two equations. I have negative 2x minus 5 is greater than or equal to 5. So I'm going to rewrite exactly what this says. Then my second inequality is going to say negative 2x minus 5 is less than or equal to negative 5. So it's super important to remember to flip the sign for your second inequality and take the opposite of the number given. So again, I have negative 2x minus 5 is greater than or equal to 5, and negative 2x minus 5 is less than or equal to negative 5. And I'm going to solve both of these inequalities just like I did for the equations. So I'm adding 5 to both sides and dividing by negative 2, and now I'm dividing by a negative, so I have to flip this sign. So 10 divided by negative 2, I have x is less than or equal to negative 5 because my sign flipped. On this side, I add 5, and again, I'm dividing by that negative 2 out front. So it started with negative 2x is less than or equal to 0, and when I divide by the negative 2, I have x is greater than or equal to 0 because that sign flips when you divide by that negative. On my number line, I have my two solutions. X is less than or equal to negative 5, and x is greater than or equal to 0. So I put negative 5 and 0 on my number line. Because it's less than or equal to and greater than or equal to, I have closed circles on the number line. And then x is less than or equal to negative 5, the arrow points that way, so I shade in this way. And x is greater than or equal to 0, the arrow points this way, so I shade in this way. When I'm writing my interval notation from left to right, my arrow is shaded in, so I have negative infinity to negative 5. Parentheses always with infinities, and my 5 is a closed-in circle, so I have a bracket here. 0 to infinity, so 0 comma infinity. Now I have a closed circle at 0, so I have a bracket. And again, my infinity always gets a parenthesis. I have a union because I have two different solution sets. I have this solution set that corresponds with this, and this solution set that corresponds with that. So I need the union in between my two interval notation solution set.